adding on to what Deepak said, right? So there is a, like, say, there is a, the industry is, light years ahead of academia, and there is a lot of gap to bridge between the industry and academia. And also the finishing schools that Raghu talked about, where it's like a crash course where at least they get up to speed, know the basics and all of that. So where do you think the industry and academia could collaborate, with expecting the least the government could do to facilitate this, and not put in more restrictions on top of this? What do you think the industry and academia could collaborate to make this talent as close to hitting the ground running as possible? What do you think, Deepak?
Yeah, I like one recent initiative by UGC, right? That is Professor of Practice, right? So which allows industry experts to come and engage with the institutions, right? So that's a very significant step, I would say. They have initiated. It will help in reducing this wide gap that we are seeing between the institutes and the industry, right? So institutes definitely should collaborate with industries, and make sure that the experts come to the institute. They either mentor the students with their projects, and they either mentor the projects, or they give lectures, and the trends, the way we talked about some trends and the problem areas, right? They talk about those things, so that students can venture into different research areas and then build their skills and the knowledge, right? They come and give the seminars, right? So those are the kind of things would help in reducing this gap, I feel.
So this is a very important thing what you mentioned now. If you look at people from industry are quitting their job and going to education institutes to teach, because that is open now. They can become professors after you have a certain number of years. See, the reverse should also happen. The professors and the lecturers should come to the industry. They should come and see. Rather, when I go, I invite them to come and see what is manufacturing happening. Instead of sending the students, you guys should also come and spend time to look at what kind of a manufacturing processes we're doing. So then when you spend time, you go back and be an effective teacher, or you can update and stuff like that. So the professors should come, spend some time in the industry along with students. Then you get a little bit of an experience of what you should go back and teach. So that's a very good point which UGC started and you put about.
It's a lot of synergy exchange. Just students does not matter. Even we need professors and all coming in. That's really,
especially
the point
I
is
think
very good.
Especially our field, there's a lot of gap. Maybe software or application software. I would use software in a very different way. In application software, there's not that much gap because it's easier to learn. But if I talk about system software, he talked a little bit about writing firmwares. Okay, we have divided software in a lot of fields, but see what is firmware, right? You're writing something on a chip. There's an initialization sequence, right? Students getting too much into all this application software mode. And what we're talking about, which we're missing in India, is the core technologies, which actually builds a system, which could be taking a chip, building a PCB, and how the PCB is built. Maybe second year student can do that as a project in the college. I did that in VIT. I've designed my own PCB, put 10 chips. It did not work. Okay, but the amount of learning we went through, okay, was massive. I talked with a lot of recent engineers in whatever we hire, and very few have done that in recent past. Very few have actually done a PCB design by their hand. All the tools are available. We had a very bad 1997 PC, if you remember, and a very bad Mentor graphics software, which was like without any license, right? What will you do? But if you don't do that, okay, and same applies to device driver development. If you don't do device driver development, you'll not understand basics of OS. You'll not understand things about kernel. Somehow we need to get into that. We need to get students driven for doing things like that. Things like basic PCB design, system software, right? Application software can be learned later. But these two parts we are missing. It becomes very difficult to hire candidates with this background. There's a lot of places where you need engineers, and definitely Intel also needs it, who actually knows how to write a C code, but needs to know the chip to read the specification, how a chip is accessed. That is a very, it's suddenly become a very specialized field. But engineers are supposed to know that. If you're an engineer, if you're an electronics engineer, if you're a computer engineer, I'm not saying computer science. If you're a computer engineer, you should know that as a computer engineer, there's some chip, there's some register space, and there's some way a hardware and software interact. This needs to be taught in the college, and students should strive to learn that. We are missing this piece. We are talking too much about application. We are talking too much about AI. We need to get students down to what actually is needed. Because if you're going to build all this electronic system in India, we need people who understand systems inside. You may not know chip design, but you know what chip can do. See, I work with tons of people who know what chip can do. They write very good device driver software. They understand how chip behaves. But to develop that skill, the student first needs to learn that software is not about some fancy Java environment and you're writing there. No, eventually it goes down on a chip. Because then only you know you want to tune a performance, what it means. So somehow the courseware of a computer engineer and electronics engineer is missing this piece. don't focus only on the application. Focus on databases, focus on kernels, focus on a processor or any ASIC interface. It doesn't need to be the design of the processor. So these are the skills we are missing. Then what happens is the student has to learn all that when they get into the job. When we joined CDAC, okay, in 2000, I was in CDAC after doing the VLSI course, and we developed a FPGA, and all of us were fresher, and we actually wrote, the other two fresher actually wrote a device driver on a Linux in 2000. They were B graduate, they had no idea, but they learned on their own, they wrote it, and it actually worked. Nowadays, we call it a SmartNIC, but that was a SmartNIC in 2000. What we were doing? We were doing some kind of RDMA on FPGA, and we used to call it Paramnet. You get that opportunity, but see, they're very less. In coming future, India, you're going to get a lot of such opportunities, but are the students ready?